Hey, what's up guys? Welcome to the second episode on how to build a game from start to finish. In this episode, we dive a bit into programming. Please subscribe to my channel and click that bell button to get notified every time I upload a new video. That way, you can follow along with this series. By the end of this video, you will know how to add basic movement to our player. And I'm super excited. So let's jump straight into it. Well, the first thing we need to do is to get Visual Studio to work correctly with Unity. Let's go to Edit, Preferences, under External Tools, make sure you're using Visual Studio Community under the External Script Editor. So whenever we want to code in Unity, we add something called a script. To do this, click on the object, then Add Component, scroll down to the bottom, then click Add New Script. Then we can call this whatever we want to. For now, we want to add movement to our player, so let's call this player movement and hit enter. You will see that the player has the new script attached and also it's displaying in the project panel. You can also drag the script to other objects, but that will change the object in the same way we move our player, and we surely don't want that. So we can just right click and remove the component. Now double click on the player movement script and it will open in Visual Studio. Now the first time you open Visual Studio, there will be a lot of scary things in here. The thing about learning to program is that at first we're just going to have to ignore most of the stuff that's going on. So to clean up our script a little, let's delete these two using tabs. And the only thing that we need to focus on is these two functions down here, where it says void start and void update. And these two functions will be automatically created by Unity. So let's have a look at the start function up here. Everything you add between these two curly brackets will be executed when you start the game. Let's just see how this is working by displaying a message to ourselves. To do that, we'll write debug.log. Please note that Unity is cap sensitive, so make sure that you're using the uppercase letters exactly as I do. Then we can add the brackets. Inside the brackets, we can add quotation marks, and everything that we type inside these two quotation marks will be displayed to ourselves. So let's just add hello world and close it off with a semicolon. If we now save this by pressing Ctrl and S, you'll see that it's saved in the bottom left corner. Head back into Unity and hit play, and nothing will happen in our game view. However, if we go to our console panel at the bottom, if you don't have the console panel, just go to Window under General and add the console. Let's drag this console to our panel. Now we will see that it had displayed a message displaying hello world. So the console here is used to debug our code. It allows us to write messages by using debug.log with our message, and it also displays warnings and errors about the code that we write. So if something isn't working in your game, you can just head over to the console and check if there is any errors or warnings. That might help you troubleshoot the problem. So writing hello world in the console is pretty boring. Let's have a look at what else we can do. Well, in fact, we can do pretty much everything in Unity. We can modify values, we can add forces to objects, we can add explosions, create game timers and menus. The possibilities is endless. And what makes it scary is that you have a lot of functionality available to you. So let's try and focus on a specific problem. Let's open the rigid body and let's say you want to disable the use gravity. We need to first reference this rigid body in our script. To do that, head over to the script. Then on top of the start function, we add a new line of code. Public, to make it visible in our inspector. Add the component you are looking for. We can get the component box collider, transform, but in this instance, we need to reference our rigid body. So type rigid body and it will autofill. And then we need to give it a name that we will use internally. So let's just call this player RB. If we say that and head back to Unity, we can see that a new empty slot is available for us. And now we need to drag our player rigid body onto our empty slot. So whenever we write player RB in our script, it will refer to our player rigid body. Now if we head over to Visual Studio, we can replace this debug.log message and write playerRB.useGravity. We can set that either to true or false, and we want to change it to false in our case, and then of course we need to end with a semicolon. So let's save this and head back into Unity. And now if we hit play, we can see that the use gravity is disabled. So let's duplicate the player to see what it does. And of course, it gives us this very cool effect. But this is just editing a tiny property. We can also make our rigid body do different things. If we quit play and head into Visual Studio, we can actually add a force to that. We can do that by clearing the use gravity and add .add force. And then again, we open and close brackets, and at the end, we use a semicolon. Now we can see that the add force is underlined in red, because we need to specify a few things. These are called function arguments. The add force method wants to know how much force to add in the different directions. So we can add 200 on the X, 500 on the Y, and 0 on the Z. Notice how I separate each number with a comma. Now if we hit save and head back into Unity, hit play, we can see that the force is being applied to the player. That's awesome! Now if we hit stop and head over to Visual Studio, we actually don't want a force in the beginning of the game. We want to add a constant force to the object sideways. To do that, we can't use the start function. Remember that this is only called once when the game starts. But remember that our update function is called once per frame. So let's add the force in the update function by writing player RB.add force 200 on the X, 0 on the Y, and 0 on the Z. And of course, remember to close it off with a semicolon. Then we can take the entire start function and delete it. Now hit save and head back into Unity. Hit play, and we should see our cube launching right off the screen. Now it seems like we don't have any errors. But actually we do. Frame rates depend on the type of computer and device you're running. So the force will vary based on the device or computer that you run the game on. To fix this, we need to head over to Visual Studio, and in our add force method, we need to multiply our number with time.delta time. And this provides the time between the current and previous frames, which will make the force the same on whatever device you're running on. So if we now hit save and head back to Unity, hit play, we would see a pretty big difference, and that is our cube is not moving at all. The runaround for this is super simple. Head over to Visual Studio and increase the number of force to add. I'm just going to add a number 0. Now hit save and head back into Unity. Hit play, we would see it just storm off to the right. It doesn't look like much difference, but at least now we can know that it runs exactly the same on all systems. The final thing that I will do is some of those things that doesn't look wrong but is actually wrong. So let's head over to Visual Studio. Unity really likes it if we use all physics in the fixed update. So let's change update to fixed update. So just make sure that if you're using physics stuff in your game, then you add it under fixed update rather than update function. That way it will look a lot smoother when you collide with other objects. Also, it may seem a little confusing at times, but a great thing we can do is add comments to our script. You can see above the update function that there is a comment stating update is called once per frame. And to add a comment, you just need to use the 2 slashes at the beginning of the sentence. And this will allow you to add comments to make it a bit more readable in future. We can add it to the top of our variable. Let's change this to this is a reference. You can also add comments at the end of the line. I see a lot of programmers using space to fill up the gaps. I find it easier to just press tab. So let's just save our code a final time, head back into Unity and enjoy the result. And that's all for this video. In the next episode, we will take a look at variables, if statements and more to make our player move. So be sure to subscribe to my channel and click that bell button to get notified every time I upload a new video. That way you can follow along with the series. And also, if you're a fan of this page, then please support me over at Patreon by going to patreon.com/mjdev. So thank you guys for watching this video, and I will see you in the next video.